Hello everybody, hope you guys are doing well. So continuing our journey in JavaScript, today we will be starting with asynchronous JavaScript. And before we go ahead, so yeah, like we will try to cover this part as much as possible, and then we will do some coding. Okay, so asynchronous JavaScript. Now this is one of the most important topics in JavaScript. Now, some computer programs, such as scientific simulations and machine learning models, are compound bound. They run continuously without pause until they have computed their result. The most real world programming are the most real world programs are significantly asynchronous, means they have to stop computing while waiting for data to arrive or for some event to occur. JavaScript programs in a web browser are typically event driven, meaning that they wait for user to click or tap before they actually do anything, and JavaScript based servers typically wait for client to request to arrive over the network before they do anything. This kind of synchronous programming is commonplace in JavaScript. And this chapter basically, so we will be studying how it is going to be easy to work with asynchronous code. The promises in ES6 is basically that represent the not yet available result of the synchronous operation is one of the most important features. Now, keywords async and await are introduced in years 2017 and provide new syntax that simplifies synchronous programming, allowing you to structure a promise-based code as if it was synchronous. Finally, asynchronous iterators, and the for await loop came in ES18 and allow you to work with streams of asynchronous events even using simple loops that appear as synchronous. Ironically, even though JavaScript provides these powerful features for working with asynchronous code, there are no features for the core language that are themselves. So basically, what he's trying to say is JavaScript inherently is a synchronous language. Um, it is uh, by default synchronous. Synchronous. Now, okay. Now let's see. So, asynchronous can be achieved using many ways, right? So let us see like the different ways you can in achieve asynchronous programming. Now you are able to do asynchronous because the engine has a feature called as an event loop that makes this asynchronous programming being available to you. So there are different methods or ways you can do asynchronous. The first is basically something called as callbacks. So this is the first way you can do asynchronous programming. The next way you can do asynchronous programming is something called as promises. And there is a issue with callbacks, right? So callbacks are not always reliable, especially when we have nested callbacks or when we go to a callback else. Now, async await, this is basically a way of writing promises so that it looks like as if we are doing it asynchronous. So this is, I can say these both are the same thing. It's just the way it is written is a bit different. So these are basically both are basically same. It's a way of writing promises only. Now, so promises was introduced in came in year 6. So let's write little bit when it came. So it came in year 6, and then later on in ES 2018 they introduced this async await. So ES is basically standard of ECMAScript standard. Basically, any programming languages that defines those standards are said to be following that standard. So that is how it is said. So the first method that we studied is callbacks, right? So basically, the first method that we have is a callback. Now it is the most fundamental level of synchronous programming in JavaScript. It is done with callbacks. A callback is a function that you write and then pass to some other function, because JavaScript functions can be passed, right? So you can do something like pass functions, right? So basically, when some condition is met or some asynchronous argument occurs, the callback is called. The invocation of the callback function offers you provide notify you pro function you provide notifies you of the condition or event, and sometimes the invocation will include for function arguments that provide additional details. This is easier to understand with some concrete examples. Now we'll see some where we are using callbacks. Okay, so first is basically the first kind or the simplest. Now, where we'll be using synchronous programming, right? For example, timers. If you see the event loop, so there is 6 to 7 ways where you can. So this is basically the event loop, right? Okay, now so basically it will look for 6 to 7 of these events. So let's see. Okay, so first is basically you have no, this is okay. Remember, this asynchronous programming are not a part of these are basically called as APIs. Remember, the reason we call them as APIs is because inherently these will involve kernel calling, right? And so basically, there in if you see, so this is indirectly it is going to call the kernel. So before we go there, let's see. I mean, let's see what is going to happen, right? So let's before we go with callbacks, let's see the architecture. I would say this is uh, this is what is going to define, right? This is how Node.js is inside it's built, right? So basically, you have the V8 engine. And let's try to understand the what do you say the function of each thing. So additionally, this is my engine. Remember, the job of engine basically to produce machine code that can be worked upon by the CPU. So machine code is what it is going to produce. Now, so now remember, and so there is one more thing which is missing is this machine code has access to memory, right? So you can have that being present here. So you can just say that your memory cell is present. This is my memory. Now, what is going to happen is the way it is going to work is yeah. So this is my libuv. So remember, whenever you need such as a network call or something, you need the physical chip, right? So you in the processor you have this network, you have this process. Basically, you need these OS related functions to be active, right? So now what so that interface is provided by this libuv, right? So this libuv is a library. This is written in C language, and then it's basically or it's responsible for providing the asynchronous IO. Now this whole is basically so the JavaScript engine is only this, right? This is basically the extra part or the way Node.js adds asynchronous programming. Now what happens is the moment you get an asynchronous thing, it comes out and it is put it in this so there is this event loop is running, right? It keeps so there are different levels in the event loop which is being checked. The and this is going to so it's said to be event driven is because at each level we are going to check whether that event has expired or not, so hence it is event driven. Now the so why is it not so there are other architectures as well, right? I mean, you could have interrupts as well, right? So basically, that is how, or that is the usage of JS, right? You want something to occur when you want, right? For example, or for example, when an event occurs, right? For example, you have a button and you want to trigger some action. So what you do is basically you click that button, and on that click, some action is getting triggered. So basically, that is nothing but an event which is occurring, right? These network and these processes are basically, these are this will be basically present or a part of OS, right? So now so these like set timeout and other functions are called as APIs, is because so API is basically an application programming interface, right? So it kind of um, instead of you calling the OS directly, or instead of, so OS, if you see, it has two parts, right? On a brief level, you see modern OS is divided into generally into two parts. So one is you have the kernel level working. So this is my okay. So this is my application mode or user mode, and then you have something called as the kernel mode, right? So you don't want the user to access the kernel, right, directly. For that, you have something called as system calls, right? So you don't access the kernel directly. Instead, what you will do is, so basically, this is where the uh, uh, so the kernel has the access to the hardware, right? The kernel can, so below the kernel is the hardware, right? So here is where you have the hardware which is being present. Now the user cannot directly access the kernel. Instead, what it does is it makes use of system calls, right? So one of the famous system calls is something called as fork. So forking is basically again to access the kernel, right? So it is, no, it is not one, like it does not access the kernel. It is like it is a system call, and it kind of does child process creation. So now so uh, you need someone or some system call that is going to invoke the kernel, right? So at user level, what modern languages have done is they have integrated certain APIs. So the job of this API, now it becomes very difficult to handle this system call code, right? Because this will be written in a language which is very close to the hardware, maybe in C or C++. So what languages have done is they provide this API, right? So instead, what you do is you basically call the API, which in basically is going to trigger the underlying which is somewhat going to trigger a system call to access the kernel, and then that kernel is going to the hardware. Now hence it is called as an API. So basically, remember, we say so what all functions that we are going to study are, those are all the APIs. Like those are not inherently part of JS, because JS is synchronous, right? We are now something doing asynchronous programming. So these are hence these are not called as a part, since they are like, no, not synchronous. We are doing something called as asynchronous, which is not inherently how JS behaves. So we will be and then again, so that it kind of provides that interface. So hence this is basically what we mean by an application programming interface, right? Now the first argument to set timeout is okay. So now this event loop kind of keeps up running at a time. Now it checks at each level whether there are different events that it check for. Now okay, there are specific events that it checks. I don't know whether that event have been written. No. So there are 2 3 events that it is continuously. Oh yeah. Okay, this is a better thing. Oh, this is by IBM. Good. Yeah, so this is a more in-depth version of what all events the callback is okay. Okay, so now this is the event loop. So you have this is what how our main. So whenever we get an asynchronous task, we come here, and then so at each level we are going to check. For example, when we go in timers, we check whether the timer has elapsed or not. If yes, then we kind of put its callback in something called as a queue, and then we work on that. So first is we check for timers, then again, so at each level, okay, so then inside this event loop, there is okay, so now certain events are prioritized over the other. For example, if you have since this is we are dealing with asynchronous programming, so promises are given a priority over timers, so that basically we will check at each level whether the promise event has expired or not before checking the other queues. So because like this is prioritized over the others, so um, before going through the different queues, we will check whether the promise queue has elapsed or not. There is one more thing. I forgot that. I guess we will check promises. There is so that queue is called as a micro task queue. Okay, so there is one, yeah, process dot next. So we will check whether this event has elapsed or not. So there are two major things, or two things which are basically given priority. Now this polling is for reading file IO. So whenever you are performing a file input output, so there is when you will be doing this reading. So it is going to take some. So as before, so this micro task queue is nothing but promise queue and the next tick. So we are going to check at every stage whether that has completed or not. If that work has been completed and the callback needs to be executed, so before coming on to the timer, the promise and next tick will be worked. Same is for different stages. Now set timeout. One of the simplest kind of asynchronous when we want to run some code after a certain amount of time it has been elapsed. For example, set timeout. And the first argument set timeout is a function, and the second is basically an interval. So let's see. Oh no, but whenever I do that. This is the syntax. How set timer is going to work. The way it's going to work is now this is a callback. This is basically a function that is going to be called. So it's called as a callback because so we say this as a callback because the moment this timer is elapsed, you are going to call for this function. So this function is not going to be immediately invoked. Instead, we are going to wait for this callback to elapse, and once it is elapsed, then we are going to call this function. So hence, we call this as a callback function because you do some work and then call me. Now this is basically a function, and this is the timer. Now remember this timer is in milliseconds. Now so again we need the hardware is going to check, right, whether this has elapsed or not. So again, hence we are going to involve the use of the hardware here, right? A set timeout calls specified call one function one time, passing no arguments, and then forgets it. If you're writing a function that really does check for updates, you probably want it to run repeatedly. You can do this. So now there is one more version for it. Uh, okay, yeah, basically what it is going to do. So once this timer elapses, we are going to call the. We are not going to call set timeout. We are going to call this function. Now, uh, okay. Now set timeout calls the specified function. So once the timer elapses, this is or the function written inside here is going to be called only once. Um, passing no arguments and then forgets about it. If you're writing a function that checks for update, so then we need to do set interval. So now there is one more asynchronous function called as set interval. You can do this by using set interval. Now set interval. Okay. Now how is set interval going to work? Okay. Um, now set interval is basically now returns a value that we can use to stop the repeated. Now invocations by calling. Okay. Now what are we doing here? Now call check for updates in 1 minute and then again every minute after that. This is in milliseconds, so basically this is 1 minute. That is what he's trying to say. This is basically the time in this is basically going to be my time in millisecond. So you have millisecond being passed. Uh, Now call check for updates in 1 minute and then again every minute after that. So so basically this is here is where I'm going to define my internal my interval. So how does this work? Okay, so after this timer is elapsed, now it is going to return some value. So this is going to return some value after the time is going to be elapsed. Okay. Uh let's see this set interval a little bit in detail. Okay. Let's go to MDN docs. So okay, let's go to MDN. Okay, let's search for set. Now, the set interval method interface repeatedly calls a function or executes a code snippet with a fixed time delay. This method return which can be uniquely identify the internal. For example, okay, now okay, so I have this my callback, then I have a time, then I have a parameter one and parameter two. So what the set interval is going to do is let's see how is this working. So let's do uh, but this is alternating between. Okay. Variables to store. So what it does is it kind of returns something. Okay, these are all deprecated ones or they're not used. So you have something. So this set interval is going to repeat something called as an interval ID. Okay, so this, yeah, that is what this value which is being returned. Now the way it is going to work is so this 1000 will elapse, and then what will happen is so what he's saying is the return interval ID is a non-numeric non-zero value which identifies the timer created by the call. This value can be passed to the clear to cancel the interval. Now, okay, the yeah, let's see. So I have set interval code and a delay. Now a function to be executed every delay milliseconds. The first execution happens after delay milliseconds. So what is going to happen is like you're kind of dividing it. So in set timeout, what it was happening is it once the timer elapses, it executes the callbacks and then it's gone, right? But here what is going to happen is now it is going to keep a um like it is going to keep a so after every interval in time it is going to execute this callback, and then it is going to return me this value. For example, first 6000 milliseconds is when my this will elapse, right? And then I will get the value. Then after the next, so basically after 1 to 12,000 milliseconds is when my next this will elapse. Then again after 18,000 millisecond is again when the timer will elapse. Then after 24,000 is when again the timer will elapse. So on and so forth, right? So this is how it is going to work. So this keeps on checking. So like after every specific interval of time mentioned here, it will execute the code. Unlike set timeout, which only executes the code, or like which once the timer has elapsed, runs the callback and then forgets about it. Okay. So this is how set interval is going to work, right? Like now there is some other functions as well, right? There is two things. One is clear interval. The clear interval, okay, this method returns an internal ID which uniquely. So yeah, how is each interval getting identified is basically by this value, right? For example, whether it was the first 6001, the next one 12,000 which occurred at 12,000, then the next which occurred at 18,000, and the next that occurred at 24,000. That each elapse is monitored by an unique ID which is being generated. Now, clear interval is basically going to uh, clear the interval. So, what does the clear interval method interface cancels the timed repeating action which was previously established by the interval if the parameter provided does not identify. Okay. So now what it is going to do is it is going to stop the interval. Oh, so clear interval basically stop the interval. Yeah. Okay. So this is going to keep on continuously running, right? So to stop it, we use something called as, or to end that repeatedness, we do clear interval is basically remove this, and now we don't need it. Okay. There is something called as clear timeout as well. If you go to set timeout, so there is another function called as clear timeout. Now what does that do? This is going to set the time. Also clear timeout, let's say. Now clear timeout is basically cancels a timeout previously established. Identify the timeout you want to cancel. Okay, so Yeah, so selects every okay, let's see. So for example, I have an alarm. So this alarm has to run after a certain number of time, right? Now I do a set timeout. This is the first parameter is going to be my callback, and then is my time, and then is like an optional message parameter that is being passed. So what I'm going to do is I'm going to assign this. Okay, so again, how are multiple set times out being managed, right? So if you have multiple set timeout, each set timeout is going to when it expires, it's going to return a unique ID, right? So each timeout is basically going to return a unique ID or a unique value, which basically limits. So if you have multiple set timeouts, then each set timeout will be represented by a specific ID, which is being returned. So just a little recap. The first thing that we studied was set timeout, right? Okay, it's camel casing. So you have set, and then you pass in callback. This is basically a callback function, and then you have a timer, right? Now, whenever this timer is going to expire, uh, this function is going to get called only once. This is only once calling, and to indicate the expiry, we are going to this is the set timeout is going to return a unique identification value or an ID. So what if we so what if we have multiple set timeouts in a line? So each set timeout triggering will be represented by a specific ID, right? So this will be one ID, this will be one ID. So each will have its own unique identification, right? So um, every one of them will have its own unique identity. Okay, now let's so the moment you clear this ID, basically you have cleared the timeout, right? So what do you mean by clearing the timeout? I mean, okay, just let me check more about this. So it is used to cancel a previously set timeout. For example, I have set a timeout here. Basically, yeah. So by clearing the timer, okay, now, yeah, this is a little bit different. So clear timeout. When used with uh, because the moment the timer starts. Okay, so yeah, this is not when the ID is not returned after the timer expires. This is basically when we kind of set the or perform the set timeout instance. It like start this set timer that we get at that time we get a ID, right? So when it is used with set timeout, we are going to uh, stop the already running timer. So which has not expired, right? Like which has not expired or not completed. Because this set timeout will happen asynchronous, right? I mean, JavaScript will not wait for anything, right? For example, what I'm trying to say is, suppose if this is my code, right? So the moment I reach this line in the background, the timer will start, right? And an ID will be returned over here. So JavaScript will then move on to this statement. And since I'm using the same ID which is being passed here, I'm clearing it out. So before it expires, we have cancelled it. So yeah, because this is going to happen asynchronous, right? So that event loop is, and then you will be maintaining that queue, right? The moment it is going to expire, it is going to say to the event queue that I'm expired, and then it is going to be placed in my call stack for execution, right? Like the function that is passed will be, the callback is going to be placed in my callbacks, in my callback, in my stack, in the main stack. So similarly, the other thing that we studied was clear interval, right? So let's say clear interval. Now clear interval, and then you have a callback being passed there, and then you have a delay or a timer. Now the moment, same again, the moment you set this or the moment you set an interval, you will be getting an ID associated, right? So this, so uh so by me, so why did I write clear? Or this has to be set. So what this delay is going to do is, by setting an interval, I'm saying after specific amount of time, uh, perform the inner function repeatedly. And then the way to stop the interval or the way to end the interval is, you then give it to clear timeout or pass this ID that is generated the moment you, okay, this is set. And you have a callback, you have a callback being passed and a value, right? So the way this is going to work is, you're going to, so the moment you reach this statement and unique ID is returned, indicating like which interval I'm in. So after the first interval, the main or the main differences, like this callback is called after a specific interval of time, right? So after each interval of time, we are going to call this. Now, what that interval of time is going to be defined by this delay, right? So again, if you want the next interval not to be called, what you do is you clear that ID associated with that interval, and the next time it won't be calling that interval. Yeah, so I guess this is all for set timeout and set interval. We'll do some code and then we'll see you, and I'll see you in the next one. Till that time, take care. Bye bye.